shift the focus back to the client side and show you how you can round out the user experience of your app with respect to security. That will include showing a technique for renewing your access tokens when they are due to expire. I'll also show how to provide the client side with enough security information about the logged in user to tailor their experience in the app based on their identity, what roles they're associated with, and what permissions they have. So first up, I'm going to revisit token management. If you recall from earlier in the course, I briefly covered the topic of refresh tokens as part of the auth6 spec, but said they do not apply to Angular apps because they should not be returned to the client side because it opens a significant security vulnerability. However, there is a technique you can use, depending on the identity provider you are using, to get a new access token when your current one is about to expire. Next up, I've emphasized several times throughout the course that none of the code running within your Angular app code is really secure. It can be easily changed by simply accessing the browser debugging tools. However, that doesn't mean you should give up on enforcing anything on the client side. While doing so may not be truly securing anything, you should still provide a sensible and coherent user experience that aligns with what the user is allowed to do in the application as a whole, which includes the front-end and back-end APIs. So I'll show you an approach for letting the client retrieve what I'll call a client-side security context that informs the client code about what roles and permissions the user has. Using that information, you can leverage features like Angular data binding to hide, show, or disable UI elements like menus, as well as using Angular route guards to block navigation to views that the current user should not be able to access. Finally, I'll demonstrate that you don't have to do anything special beyond what I covered in this course for multiple apps that use the same STS to have a single sign-on experience across those apps. One challenge with auth2 access tokens is that they have a fixed expiration time. That means if your user just finished filling out a long form of data that took 30 minutes to complete, the call to the server to save that data is going to result in an unauthorized response from the server, which means at that point you need to redirect the user to the STS to log in again to get a new token. And the redirect to the STS means your Angular app is fully unloaded from memory. So unless your Angular app is auto-saving the user's work or persists the unsaved data locally before it redirects to the STS, the user could lose all their work. Not the way to have happy users. No problem, you say. I'll just crank up the expiration of my tokens to 1 day or 10 days or a year. Just keep in mind, the longer that access token is valid, especially if you change user manager settings to store the token in local storage instead of local session, that just opens the window of opportunity for a hacker to get their hands on and use your token before it expires and becomes useless to them. So we really need a way to logically refresh an access token, but we can't use the refresh tokens of OAuth because they can't be used securely from a client JavaScript app. So what do? When you log into an identity provider with OpenID Connect, as I covered earlier in the course, the identity provider will typically establish a cookie-based secure session between the user's browser and the identity provider site itself. That means that anytime a request is sent from the browser to the identity provider site, the browser will send the authentication session cookie along with that request. And that cookie-based session is typically a sliding session. So each time your app makes a request to the STS, it resets the expiration of the cookie. This includes requests to obtain a new auth2 access token. So if the expiration of the login session with the identity provider is longer than the expiration of the authorization token, the identity provider can support issuing a new access token as long as the session with the IDP is still active. This allows you to get the same effect as a sliding expiration of the access token, even though doing so is not explicitly part of the protocol. Since we are talking about security here, you should be asking yourself right now whether this is a good idea. After all, it basically sounds like you're trying to hack your way around the protocol, right? Well, to answer that, you have to understand well how cookie-based authentication sessions work for your backend. The reason that many systems are moving away from cookie-based authentication is not because of any inherent weakness or vulnerability. As long as you correctly use a respectable framework or library to issue and manage your authorization cookies, the cookies will be HTTP-only cookies, which prevents any client-side script access to them. The cookies will also be same-site, meaning the cookies will only be returned by the browser automatically for requests to the same site as the hosting page. So that mitigates some of the cross-site request forgery or CSRF vulnerabilities. The downside to cookies in general is that there are significant cross-site scripting, or XSS, and CSRF, cross-site request forgery, vulnerabilities that you need to mitigate in your code. Additionally, one of the big driving factors moving organizations away from cookies is the desire for single sign-on across a suite of applications or organization tenants. And the protocols that enable that are centered on tokens as a more general purpose form of credential than cookies. And tokens do not have most of the XSS and CSRF vulnerabilities that cookies do. But for single-site access, cookies work great, are secure when properly implemented and used, and can easily support sliding expiration in ways that tokens generally cannot on their own. And for OIDC client applications, if the session with the STS is still alive, it means the user is still running the browser. They may be working in another tab or have even navigated to a different site, but there is a direct tie to an interactive user session. With tokens, there is not, because remember, OAuth tokens can be used with non-interactive background server-to-server communications as well. So it turns out the best approach for a single-page app or a client JavaScript app is to leverage both. Have a cookie-based authentication session with the STS, and use OpenID Connect and auth2 for tokens used between your client apps and back-end resources. So given that you will usually have a cookie-based session with the STS, what we can do is leverage that fact to use a sliding expiration secure session with the STS to periodically go back to the STS and get a new access token as long as our cookie-based session is still alive. The way this is done is to use a hidden iframe in your app to issue a request to the authorization endpoint for your STS, just like the way you redirect to that endpoint for initial login. That request can and should include a parameter that is part of the OpenID Connect protocol named prompt. That prompt parameter should be set to none, which tells the STS to try to authenticate the user without prompting or trying to show any kind of UI, which it can succeed in doing if the session cookie with the STS is still valid. If that call succeeds, the STS will return a new access token, just like it did when the user first logged in and got the original access token. Then you just replace the old access token and start using the new one for subsequent requests to your APIs. Now this all probably sounds a little complicated to implement right, and it is. The good news is you don't have to. OIDC Client has already done it for you. With OIDC Client, all you have to do is tell it you want to enable silent renew and give it a redirect callback URL for the silent renewal process completion. Then OIDC Client User Manager will keep an eye on the expiration of the tokens it has obtained for you. It will create the hidden iframe for you, issue the authorization request, and create a new user instance with the new tokens once it gets them. So let's go add that and see it working in a demo. In this demo, I want to show you how to enable silent renewal of your access tokens from the STS. First, let's take a look at what is happening with our access tokens right now before I make any changes to refresh your memory. If I go run the app and log in as a user, I can go to the Browser Debugger Application tab and grab the access token from session storage in the debugger. Now I can go to the jot.io site again, paste in the value, and clean off the quotes and property name so I can see the decoded contents. If I look at what the expiration for the token is by hovering over the EXP claim, which is a JSON timestamp value, you can see the expiration clock time. And then if I hover over the NBF or not before claim, which is really when the token was issued, you can see that the current default expiration for Identity Server 4 is 1 hour. That's going to be a little long to make you wait in a demo to see expiration happen. So I'm going to go to my Identity Server 4 STS code and change the configuration for our client app to set the lifetime of the access token to 30 seconds. With that change, I'll go and log out and log back in to get a new token, then go grab the new access token, pop it into jot.io, and now you can see the token expiration is 30 seconds after the issue. If you remember, in a previous module, I had set up data binding in the main menu of our app component so that the login and logout buttons would be shown based on whether the user is logged in or not, as well as the rest of the menu items. I also had defined an observable to allow the auth service to fire an event when login changed. However, right now that does not fire unless the isLoggedIn property is checked, or at the completion of login. I'm going to enhance that to also fire when the token expires. Also, I failed to fire that observable when the logout completes, so I'll fix that too. To do that, I'm going to go into my auth service and subscribe to an event that the user manager will raise when the access token expires. In the constructor, right after constructing the user manager, I will go to the user manager events object, add access token expired callback, and pass it an arrow function that fires the login changed observable through its subject. I'll also go down to the complete logout method and fire it there as well. Now, if I go back to the app, log out, log back in, and wait a bit with some time acceleration here, after 30 seconds, you will see the menu bar change to a logged out status because of the token expiring. Now that we know our tokens are set to expire after 30 seconds, and the app menu bar and logged in status will dynamically update to reflect that, we can add the silent renewal of our access tokens and see it working. The first step is to set a couple more properties on the settings object that we pass into the OIDC client user manager. I'll add the automatic silent renew property and set it to true. Then, hand in hand with that, I set the silent_redirect_URI property to tell the STS where to redirect to after a silent redirect to complete the process like login. Note that I'm going to handle that a little differently than our other callbacks. As I covered in an earlier module, the callback URLs I used for login and logout were client-side routes to routed views in our Angular application. Those views were only loaded momentarily, long enough to complete the login or logout process with User Manager. For Silent Renew, I don't really want to pay the overhead of loading my entire Angular app into a hidden iframe just to complete the Silent Renew process. So I'm going to create a new HTML page at this address that will do nothing but complete the Silent Renew process. So let me go add that page under the Assets folder and name it silent-callback.html. In there, I will use a code snippet to populate a basic HTML5 document structure. I'll need OIDC client loaded in this page to complete the silent renew process. But since this is just a flat HTML page, I'll have to bring that script in differently than I do in Angular. I could either link to a CDN version of the library, or create a local copy within my project that gets deployed with it. I'll do the latter. So first I'll go into my node_modules folder and drill down to OIDC client and the dist folder. I'll grab the OIDC client min.js out of there and go into assets and create a new folder named JS and paste it into there. Then I will go add a script tag in the header of my silent callback page pointing to that script. Next, I will add a script block to the body, and in there I'll create a STS settings object and set several settings to be compatible with the auth service user manager, including the authority, client ID, scope, and response type settings. Then I can new up an instance of the OIDC.userManager and then call sign-in silent callback on that instance. If there is an error, I'll dump it to the console. If it succeeds, I don't need to do anything else because it will happen in the iframe and the iframe will just be closed. If I save those changes and go back to the app and try to log in, you can see we have an error in the debugger console complaining about content security policy. It turns out this error is a distractor. You can see it's complaining about a frame ancestor setting in the content security policy. The reason for this is because if you look at that URL closely, you can see it's an error page on the STS. So as mentioned before, it's important to remember that anytime something is not working as expected with communications of any kind to the STS, the first place to look is in the STS logs. If I go to the STS console window, you can see we have a request validation error. And if I scroll up, the reason becomes more apparent. It's complaining about the redirect URI for the silent callback page, similar to an error I showed earlier in the course. Remember that your STS client settings have to match up exactly with the STS server-side client configuration. We just added a new redirect URL, but the STS doesn't know anything about that URL. So it triggers an error at the STS and tries to display an error page, but that is disallowed by the default content security policy in the iframe. So the fix is to simply go add our new callback URI into the redirect URI's property on the client configuration settings in Identity Server. In auth0 or another cloud identity provider, this would just be another configuration setting through their portal. Now, with that fix in place, I'll run the STS and API again and go back to the browser and log in, and now that error is gone. The next issue is that if we look at Fiddler or the network tab of the debugger, we can see it looks like our app is constantly calling the STS in a loop. This is because OIDC client triggers the silent renew process if it's enabled based on another event that the user manager raises, the token expiring event. And user manager fires that event 60 seconds before token expiration. Since I set my token expiration to 30 seconds, it is always within that window. So let me go change that expiration to 90 seconds, save, run, and try again. Now you can see we're not getting the constant requests going out. If I just fast forward time for 90 seconds, you can see in Fiddler a new batch of requests fired, starting with a request to the authorized endpoint, with a callback URL that is the silent callback page. Also note the parameter here in the URL that is prompt equals none, which tells the STS to only proceed if it can complete the request without prompting the user with any UI, which would include a login form or a consent screen. Then it immediately redirects back to the client callback page because the authorized endpoint call also includes the session cookie for the STS. So the authorized endpoint just looks at the request and says, okay, looks like you are already authenticated. I can just issue you a new token straight away. Then when it gets back into the script in my silent callback page, just like with a normal login, when the code calls sign in silent callback, user manager makes another request to the token endpoint with the right parameters, and that returns a new set of tokens into the app. which User Manager then uses to replace the user object it caches with a new one containing the new tokens. So now, as long as the user is in your Angular app and your session with the STS is alive, your tokens will always be valid in terms of expiration. The key thing is to just ensure your token expiration time is less than your STS session length by some margin. And then each time it gets renewed tokens, that request to the STS also slides the session so it stays alive as well. I'm going to go change the cookie timeout to 15 minutes here in startup.cs in the STS project, and then set the token expiration time to 10 minutes. That is a decent restrictive time, so the app is not hammering the STS with too many requests, but if the user navigates away from your app, the tokens in session storage will become invalid after a short while, forcing a new login when they return. Now let's start putting the finishing touches on our app with respect to security. To do so, I need to make the client code aware of a security context for the logged in user. Using that context, we can do things like hide or show things to the user based on their permissions or role, and can also block client-side navigation to pages that the user should not see. Again, always remember a hacker can go into the code in the browser and remove or change these restrictions. But that doesn't mean they are not worth doing to have an appropriate user experience for people not trying to hack the app. So first, I'm going to go to the server API project and add an endpoint that the client can call after login to get the permissions for the user. To do so, first I need some data structures to return the information I want to the client. I'll start with a class named SimpleClaim, and it will just have string properties for a type and a value. Then I'll create a class here named auth6, and we'll add properties for the user profile and a collection of simple claims. Now I'll go to the project's controller and add a new get method to return an instance of that security context, populating the user profile with the child permissions collection and populating the claims from the user principal on the controller base class. Now let me switch to the client side and start hooking up this security context. First, I'll go into the model folder and add types for the simple claim and auth context types, matching the server-side definitions. Next, I'll go into the auth service and inject the HTTP client into the constructor. I'll add a new public property to hold the loaded auth context, and I'll add a method to retrieve that security context and store the result in that property. Now I need to figure out where I should call that. I'm going to leverage another event that User Manager will raise when its cached user object loads, which happens both when login is complete, which we already had handling for, but it also happens when silent renew completes, which happens outside of our Angular app in the silent callback page. But the instance of User Manager that is alive in our app will see that the object in session storage changed and will fire this event. In that handler, I will do something similar to what is happening in isLoggedIn, and we'll check if the user actually changed, and if so, we'll update the auth service user property, load the security context, and fire the login changed observable. I'll also add a call to load security context in the isLoggedIn method, which gets called from the root page when it's populating the menu. Now let's run and make sure all is working okay. I can set a breakpoint here where the call completes and take a look at the security context to make sure it contains what we expect. I'll go log in as Alice, and then as the application is loading, it hits my breakpoint. In there, you can see that the context object contains the collection of claims and a populated user profile object. Next up, let's use that to start adding some restrictions and customize the UI. Now that there is a security context available to the client side, let's go hook it up and make sure the user experience matches what the user is allowed to do in the app. First, there will likely be checks needed in a lot of places to see if the user is an admin. So I'm going to add a convenience computed property to the auth context class named isAdmin. The value for that property is computed by seeing if the context has a role claim of admin. Then I can go to the main menu in the app component and modify the ngIf statement for the Manage Projects menu item to check whether the user is an admin or not. To do so, I'll point to a method in the app component named isAdmin, and then to implement that, I simply need to check the isAdmin property on the auth context. With that in place, I can fire up the app, sign out, sign in as an admin, and see that the Manage Projects menu is there. But then sign out and sign back in as Alice, and she no longer sees the Manage Projects menu. Next, I'll go to the project view that lists the milestones for a project. If a user does not have edit permission for this project, the edit, delete, and add buttons should be disabled, and maybe have a tooltip that tells the user why they're disabled. To do so, first I need to inject the auth service into this component. Then I'll go add a method named canEditProject. In there, I'll make sure I have a project, a security context, a user profile on that security context, and a permissions collection on the profile. Then I'll check to see if the permissions contains an edit permission for this project. Or they could be an admin who has permission for everything. So I return a result based on them either having edit permission or being an admin. Now I can go into the view markup for this project component and set the disabled property based on the call to canEditProject. I can also modify the title to be set dynamically based on whether they have edit permission. I can do the same for the delete and edit buttons as well. If I run with that code in place and do a fresh login as Alice, go into My Projects, then to the first project, which she only has view permission for, you can see the buttons get disabled and their tooltips set appropriately. Next, let's add a route guard to constrain navigation to routes that the user should not be able to go to. Non-admin account. I hide the Manage Projects menu item by data binding to the security context info. But right now that does not prevent a user from putting the address for the admin page into the address bar. And you can see it will take them there. But then if we have done our job by putting authorization checks on the back end, they should get a 403 forbidden response if they try to take any actions on that page. But of course, it would be better if they simply could not get to that page in the first place. The best way to do that in Angular is with route guards. A route guard is a class that you can wire up to a route or set of routes, and it will be consulted to decide if the navigation should be allowed. So let's go add a route guard for the admin routes. To do so, I'll go into my core module and add a new file, and I'll name that file admin-route-guard.ts. In there, I will select the code snippet for a route guard using canActivate. I'll get rid of the provided in for the reason I covered in the last module, and I'll name it admin route guard. Then I'll go add it to the providers in the core module. Back in the guard, I'll inject the auth service into the constructor. Then in the canActivate method, I can just return the value of the auth context isAdmin property. Now I'll go to the admin module, add an import to the core module, then go into the routes for the admin module and add a canActivate property to each one set to an array with my admin route guard in it. If I run now and log in as non-admin, and then try putting the /admin address into the address bar, you can see it just redirects to the root URL and does not even activate the Manage Projects component. But if I sign out and sign back in with the admin account, I can see the Manage Projects menu, and I can click there or put in the admin address in the address bar, and those still go to the pages for the admin. So that gets us pretty close to done. One other aspect I wanted to demo to wrap up, since it is a key reason for going with OpenID Connect and auth2 in your apps, is single sign-on. To demonstrate that, I need one or more other sites that are set up to use your STS as their identity provider as well. In the sample code for this module, you'll find a separate project for an ASP.NET Core MVC app. That app has been configured to use OpenID Connect and our Identity Server 4 STS, same as our Angular app. But you can see here in the OpenID configuration, it is setting a response type to code and ID_token. That corresponds to the hybrid flow I talked about earlier in the course. And if we go to the About action in the Home controller, you can see it has an Authorize attribute on it, requiring authentication to render that page, just like we did with our API methods, to accept the requests. To allow this app to use our STS as its STS, there needs to be a corresponding client configuration. So let me go add that. You can see here I'm setting the grant type to hybrid and other parameters such as the client ID, client secret, and redirect URLs. So if I fire up the STS API, this new MVC client, and our Angular app, I can go to the About page in the MVC app, which requires authorization. And you can see it redirects us to the STS just like our Angular app does. I can log in there as Alice and get redirected back to the app, and we can see the minimal content there. If I then go to localhost 4200 to access our SPA and click Login, you can see it treats us as already logged in. If you were to do a third site that used the same STS, the result would be the same. As soon as an authorization request is sent to the STS for that new site, it would detect a session already in progress and could log the third app in silently as well. So that brings us to the end of this course. In this course, you have learned about the big picture security concepts that apply to an Angular app. You learned how to use the OpenID Connect protocol to get your users logged in through an OpenID Connect identity provider, or STS. You learned how to hook up authorization based on auth2 access tokens issued as part of the OpenID Connect login process. You've seen how to use Identity Server 4 as your STS, as well as auth0. Other identity providers that support these protocols would have similar configuration options. You just have to track down how to get those configured for that provider. As you've seen, the OIDC client library does a nice job of insulating your code from needing to know too much about the OpenID Connect and auth2 protocols. It encapsulates the process of getting redirected to the identity provider, calling the token endpoint, and collecting the tokens returned and making them accessible to your code. It even makes it easy to set up silent renew to keep your secure session going as long as your session with the STS is current, even if your access tokens have shorter lifetimes. Finally, you saw how to pull some data back to the client about the security context of the user and use Angular features like data binding and route guards to enforce security constraints on the client side for user experience reasons, even if the true security can only be provided by the back-end API calls. I hope you've enjoyed this course. Please feel free to ask questions in the discussion forum for this course on the Pluralsight site. Thanks for watching.
Let's start with the first name.